Hi, my name is Struan and I'm a scientist at Izon Science, and today we'll be going through what tapping and plunging do and how to use them to stabilize your TRPS system. It's not often that you hear the technician of a scientific instrument telling you to just give it a whack, but the Xoid has been designed to take a hit. Tapping the system involves a short, sharp strike to the pressure nozzle of the Xoid with a hard object, typically using the pad like so. The purpose of this is to dislodge any blockages or bubbles in and around the nanopore by applying a kinetic shock to the nanopore cruciform, transferring enough energy to overcome the adhesion of a bubble to the plastic surface. Plunging is exactly as it sounds. The plunger end of the pad is used to apply a large pressure and vacuum shock to the system like so. This is most useful for getting air bubbles and blockages out from the inside of the nanopore. For example, the nanopore currently loaded is wet but not stable, as you can see from the high RMS noise level and fluctuating baseline. Upon administering a sharp tap to the pressure nozzle, the current stabilizes at around 124 nanoamps and the RMS noise drops to about 7 picoamps, showing the problematic bubble or blockage has been dislodged from the system. Along with the wetting step, tapping and plunging are most commonly used while running a live sample. As you can see, the calibration particles are loaded and the baseline is stable at 119 nanoamps. Upon starting the measurement, we have a blockage event occur, so the pause button is quickly selected. We then begin tapping the pressure nozzle. However, after 5 taps, the blockage is still present, so the pressure is set to 0 in order to plunge the system. A few plunges unblock the nanopore, and once pressure has been reapplied, you can see that the baseline has returned to 119 nanoamps and the RMS noise is back around 7 picoamps. This is an example of a successful intervention by the user. We have restored the baseline current to around the same value that it was before the blockage event. When the next blockage event occurs, we follow the same procedure. Pause the analysis and tap the system to remove the blockage. The second tap has returned the system again to a baseline current just below 119 nanoamps with an RMS noise of around 7, again indicating that the intervention was successful, so we can click Resume Analysis. Unfortunately, knowing when tapping will fix the problem versus when plunging will fix the problem cannot be distinguished easily. Using a combination of tapping, then if tapping is unsuccessful, plunging the system, gives you the best chance at getting a good measurement despite a blockage occurring. If you have any questions or would like to know more, please contact us at support@izon.com.